Assalamualaikum and hi, my name is Hashimawada and today I would like to present my FYP demo presentation with the title of Design and Simulation of Fuzzy Logic System for DC Motor Speed Control. So let's take a look on this slide. So this is a three objective for my project. For the first one is to design a DC motor model for speed motor control application. The second one is to design a fuzzy logic controller for DC motor speed control. And the third one for my project is to analyze and compare the performance of the fuzzy logic controller with a PID controller in terms of speed control efficiency. So for the project approach, I divided it into three parts. The first one is a project type, which is this project is simulation based and mathematical modeling. The second one is a system developed, which is through the DC motor model, transfer function, plus with the FLC as a main controller and the PID used as a performance comparison. The third one is the performance analysis is the rise time, cycle time, overshoot and the control output from this project. And you need to know that main tool used is the MATLAB, and you need to know that it is a fully simulation, no hardware required. So for the tool description and justification, MATLAB is actually the main tool and Simulink and Fuzzy Logic Toolbox only the furthest in the MATLAB. So the justification for the MATLAB is used for tuning KPKI and KD, measure overshoot rise time, settling time, and also the industry standard for control system. For the Simulink, it's more to the model of the PID, FLC, and block diagram, and also we obtain graph from that. And Fuzzy Logic Toolbox, we use to create for the Fuzzy, which is for the membership function, rule-based setup, interference system, and also it's not no coding required. Okay, now we go to the two limitations. So the first one is the manual fuzzy system setup. We need to set up one by one on the fuzzy system. The second one is the manual fuzzy tuning. This one is very challenging because we need to try and error until the exact result that we want. The third one is the auto testing function, and the last one is MATLAB requires large storage and sometimes slow down during the simulation. So this is all the changes that we're seeing through when using the MATLAB software. So for the simulation design, I want to show you the circuit design first, but this one is already be combined. But this is the circuit design for the control without controller mode, and then the upper is the fuzzy circuit model design. Model design, and on this part is the PID model design. But for this video, I want to show on how you can read the value for peak tune and for the value that is recorded on the table and at the slide. So by using this type of coding, you need to paste on the command window like this, and then after you paste, you can see that you can get the KP, KI, KD value here. Then for the settling time, after how can you get this kind of value? You need to use this kind of coding. So this coding you need to paste on this type on this command window. Then the rise time and the transit time will become up each time you're running your simulation. So next on the next slide we will present the result. So from simulation that I showed you before, so this is the result of DC motor without controller. As you can see, the main thing that I want you to see that it not achieving the set point because we know that our set point is 12 radian per second. So that's why we need to apply the controller. And on the next slide, we show you the PID and LFOC controller perform this problem. So this is the result of DC motor with PID controller. So by varying the value of KD, the best value that we get is KP 0.32, KI 0.0853, and KD 0.1. Actually, we use a PID tuning, but from this very varying condition, we can see that this is the best optimal result for PID. So this is the result for DC motor with FLC controller. In FLC, we also vary the gain value, but the best gain value that we will choose is 3.5 because of what? Because as you can see from the black graph, the optimal result get for when we use the FLC gain value. FLC gain value 3.5. So after that, we need to combine the best PID result, FLC result, and the without controller situation in a graph, and we need to compare. And after running, we can see that FLC obtained the best value of rise time, settle time, and overshoot, which is the lowest value on each of that. So it is proof that my FLC work on this project. So we got three conclusions that we can see here. The first one is a MATLAB tools enable full design and simulation of the control system. The second one is a FLC developed easily via fuzzy logic toolbox and no coding required. And the third one is that we learn both advanced advantages and limits of using simulation based tools. So that's all from me. Thank you for listening.